Hi, this is our presentation on Sea-lution, which is a simulation-based solution to solving catastrophic sea level rise in coastal communities by myself and Vivaan Pradhan. So this is the table of contents of what we'll be discussing today, and at the end we'll have a demonstration. So this is brainstorming. So we had 4 initial ideas, but we decided to focus on a 3D simulation of Kili, which is a small island in the Marshall Island region, which is at high risk of sea level rise destroying wildlife habitat and the homes of its inhabitants. Simulation is targeted to global policymakers who can use the inbuilt GPT API to type and see the impact of different environmental legislations, for example, like banning PCPs, what impact that'll have on the sea level in Kili, and watch the sea level rise and fall. And they can also see the impact on greenhouse gas concentrations, such as CO2. And this encourages the enactment of better environmental policies. So diagnosing the problem. So there are many statistics that talk about the danger of sea level rise. For example, almost half of the Marshall Island region, its residents interviewed said that they'd been directly impacted by sea level rise. And so we did some research and we found that the main factors contributing to this around the globe are greenhouse gases such as CO2, CFCs, etc., which are trapping heat and decrease global albedo, which is the ability of the Earth to reflect sunlight. We focused on the first problem, which is the largest contributor, which is greenhouse gases. So our technology stacked. So we used Unity 3D engine to build the 3D game, and we used C# and visual scripting. How visual scripting works is that there are game objects, scripts, and components, functions, and properties in the scripts. So the scripts code is for behaviors of game objects, and the functions and the properties help to accomplish these behaviors. So Blenders and Unity store assets are basically things like trees and stuff, which we help to design our game, and we use the ChatGPT API at the end. So this is how we designed the island. So we use the Unity terrain tool to shape and terraform the island and add miniature islands around it and stuff like that. And then we created assets for all the things you see, such as boats, homes, trees, etc. Finally, we used the terrain paint trees tool to see the forest that you can see on the island. So how did the ChatGPT API integration work? So how we did this is we used the OK Go Do It API, which uses a .NET framework in C#, which is used for all types of internet requests, and in our case, to query GPT API. For our model, we're using GPT 3.5 Turbo. Basically, there are 3 categories of messenger users, assistant, and system. The first code screenshot, and you can see that we created a system message, and this tells GPT what its role is and what it needs to do. As you can see, it's talking about how you are analyzing how policies ... Then in the second code screenshot, it gets the user message from the input field where they typed it. And finally, in the third code screenshot, it calls the API and creates a chat request. Temperature is how realistic or creative it should be. 0 is full, realistic. 1 is fully creative. Since we're prioritizing accuracy, we chose temperature of 0.1. All messages are stored in a list of chat messages, and each time we query the API, it looks at the whole list for context. Finally, we can see the response in the list of messages. And the relevancy of this using GPT is it helps the user receive accurate information and feedback on their suggestions. For example, if it's realistic, how hard it'd be to implement. Additionally, the GPT API can interact with the actual game and adjust the sea levels and greenhouse gas concentrations. So we used real EU and US climate data to model the greenhouse levels. We accessed past historical greenhouse data, and this is what we model it on. And we calculated the greenhouse warming potential for each greenhouse gas, and we implemented that into the sliders we can see on the first screenshot. And for example, the warming potential for CO2 is 1, and the other 8 greenhouse gases are scaled to it. So we also use NASA's sea level rise projection tool, and we use this, which uses satellites to measure the sea level rise based on the mean surface level temperature. And this is like how the greenhouse gases affect the sea level rise. And instead of doing this, we model this by using an exponential projection how the change in MLT will affect the sea level at the island. And this allowed us to translate the greenhouse gas concentration to the sea level rise. So roadblocks and improvements. So I'll go through 2 of these. And initially, we struggled to use the train tool because it was our first time using it, and we were unable to use the paint tree tool because there's not a mesh layer on the prefab. So what we had to do is we actually had to go in, import all the parts of the prefab into Blender, and then merge them all into single object, and then it had a single mesh layer. And also there's no apparent NASA API, which we could import the greenhouse gas data for the nice greenhouse gases. And to solve this, we just use an exponential model based on the NASA API, and this helped keep it realistic. For the teamwork, I was in charge of terraforming the island, creating ocean waves animations. I imported all the assets for trees, homes, textures, and created some of them on Blender too. I designed the UI for the GPT input box, output box, and sliders, and I worked on the prompt engineering. Vaughn imported the AI, the UIs themselves. He researched the NASA greenhouse gas data and ensured realistic measurements. He imported and implemented the GPT API and implemented realistic sea level rise. Now for the demonstration.
As you can see, this is the island of Keely from the Marshall Islands, and in real life, it has an estimated population of 400 people. You can press this Show UI button to turn on and off the UI. And for now, I'm actually going to turn off this passing of years to pause the sea level rise. As you can see, we have trees, mini islands, ships, and huts. And the reason why we chose the Marshall Islands is because this is one of the islands that is most prone to sea level rise because the max elevation on this island is only 10 feet. Now, if I return on this, the time is passing. I turn it to the max, and I also increase the emissions. As you can see, the island and the sand will slowly disappear as the sea level continues to rise higher and higher. And I'll just wait for that to take effect. So you can see slowly and steadily the water is continuing to rise and rise, expanding and making it so that it is encroaching on this very island. But what we can do is we can use this to propose policies. And what happens is that GPT provides provides an analysis of these policies, but also, as you notice, it decreased the carbon dioxide slider. It affects the greenhouse gas concentrations, which allows you to see how real policies can curb the effects of sea level rise.